This is Mrs. O'Neill for AP Chemistry, Chapter 2, Section 7, Ions and Ionic Compounds. Mainly this is going to be more about ions and polyatomic ions. Ionic compounds will come next section. In this particular section, you should learn that atoms can gain or lose electrons, and when they do, they form ions. You should be able to use your periodic table to predict the charges on those particular ions, depending on the group that they're in on the periodic table. Again, this is more review from Chem 1, but this might be a particular section or video that you might want to keep on hand and refer back to it as we go through the course. So what's an ion? Before I talk, I want to remind you that you may want to pause the video, fill in the blanks in your packet, and then play to hear my words. So ions are just an atom with a charge, and there are two different charges. Atoms can form positive charges, and they can form negative charges. So when they form positive charges, we call them cations, and that's because they lost electrons. They now have more protons, which are positively charged, than electrons, which are negatively charged, and that's why they're positively charged ions. For the negative ions, we call them anions, and they gain electrons, and that's how they become negative, because now they have more negative electrons than they do protons. So if we want to predict ionic charges on the periodic table, there's trends. Love the periodic table because of all the trends that it gives us. So you might want to bring back your blank periodic table. Hopefully on one side, you'll be able to write this information on the top that you didn't use too much of it. So here are the trends, again, which you should know. All of group 1 are going to contain +1 charge. All of group 2, when those atoms become ions, lose electrons, so they become a -2 charge. These transition elements, we're not going to give them charges yet. We're going to talk about them in more detail later, about how they form multiple charges. Again, most of the group in group 13 will have a +3 charge, a little bit more specifically the top 2. Then we're going to skip a group because those guys can be positive or -4 actually. And because of that, sometimes we don't even label them yet because they can go either way. And then we have -3, -3 charges, -2 charges, and -1 charges for most of those halogens. And notice again, the noble gases do not have a charge because they are stable. They do not contain a charge. They're already happy as they are. So then what's a polyatomic ion? Those are a group of atoms that have a charge. And yes, you do need to memorize most of them. So I will actually talk about a mnemonic for you in a minute. So let's see how many you know. So quiz yourself. So I will go through this. You might want to, I believe I give you the name. See if you can come up with the polyatomic ion formula with its charge, positive, negative, and go through it. I'm just going to kind of go through the video pretty quickly here. So again, you might want to pause and quiz yourself as we go through. Ammonium, NH4, 1+. Chlorate, ClO3, -1. Just want to bring to your attention, here I have the number, then the positive. Here I have the negative and then the number. It doesn't matter which way. I've seen it both ways. Sometimes your textbooks write it one way, other textbooks write it a different way. It really doesn't matter. As long as when you have a charge, I just always recommend you putting a positive, negative, and a number. Hydroxide. This one you got to know by the back of your hand, especially when we get to acids and bases. All bases have OH, 1-. Phosphate. PO4, -3. Nitrate. NO3, 1-. Sulfate. SO4, SO4, -2. Hydrogen sulfate. I'm going to go back real quick. This is sulfate. So what's hydrogen sulfate going to do? What happens if we have an H here? If we're adding an H, we're actually adding a plus charge with it, right? Because remember that hydrogen is really going to be a proton by itself. So hydrogen is going to add a plus charge to this. So hydrogen sulfate is HSO4, 1 negative. It's also known as bisulfate, but here's some information on that. The bi form is actually an older form, and the hydrogen form is now preferred because it actually describes the form of the compound. Well, they're going to call it a compound, but the structure of that polyatomic ion. And if you'd like to read this information, you may pause the video. It talks about what does preferred mean and the IUPAC of the naming system of ions and compounds. The next one, carbonate. CO3 negative 2. Acetate. Again, this is going to be a big one. This one you got to know by the back of your hand because we're going to be talking a lot about acetic acid, which has C2H3O2, 1 negative in it. That's the polyatomic ion. So make sure you know that. So what I'd like to do actually is go over a mnemonic called Slifka square that will help you understand and be able to make these polyatomic ions using the periodic table. So why do I want you to do this? Because understanding how to name these ions or polyatomic ions will help you name acids. So when we know what the name of the ion is, if we can take that from the acid, we can it's going to be easier to name the actual acid compounds. So I like to call this Slivka square. I actually learned this when I was student teaching, and I've kept it ever since. It's a great mnemonic, how to use the periodic table and the trends, of course, that it has to make polyatomic ions and their charges. So polyatomic ions actually have like ion families, okay? So if we look at nitrate, okay, so 8 is like the original form, but if we only take one oxygen away, we're going from a 3 to a 2, everything else stays the same. Nitrate, NO3 negative 1, nitrite, NO2 negative 1. So I took an oxygen away, one less oxygen, I'm going to change the ending to 8 to 8. Another thing to remember, just like you did the sulfate to hydrogen sulfate, anything carbonate to hydrogen carbonate, it's the same concept. So we have CO3 negative 2 is your original carbonate, but when we add that H plus, right, we're really adding a proton, so we're taking one of the electrons away or canceling out that charge, so it's HCO3, and we're just adding the hydrogen to it. And again, sometimes you'll see it as bicarbonate, but not often. So what does this mean? This is the true family that I'm going to talk about. So if we start with 8 and we take one away, like we did up here with the nitrate and nitrite, so the 8 becomes 8. Notice all I did was change the number of oxygens. The chlorine stays the same and the charge stays the same. What else we're going to learn is if you take 2 away, it's going to be hypochlorite. So we're changing the name again. And if we go back to the general form, that's how I like to call it, and we add an oxygen, it's going to be perchlorate. So this I have very similar, but I think I have it backwards or the opposite way in the notes. So let's get to that. So this is called Slivka square, and arsenic is going to be the reference element. And around arsenic is going to form a square, and then around that forms a 7. So I'm going to show you that on the periodic table. So I'm going to refer to the square section and the 7 section quite often. So here we go. Here's arsenic. So that's our reference point. And if you notice, all of the elements that surround it form a square. The other elements, if we kind of take that away and look at the blue section, that's going to be the 7th section. It looks like the 7, okay? And that's going to be important in a minute. So again, where on the periodic table you have your arsenic reference is right there, reference element. You have the square around it, which is pink, and I'm going to keep that pink. And the 7th section is green, and I'm going to keep that green, just like I did back here. So we have the yellow square section, and we have the blue, or I'm sorry, the green 7th section. So that's where it is on the periodic table. So you might want to, I guess I'm going to bring this back. You might want to somehow put this on your periodic table with the charges, because those are going to be important. These charges are different. These charges are not the charges when these elements become ion. These charges are when phosphorus combines with oxygen to make phosphate. And so PO4 is going to have a -3 charge. And again, I'll show you that in a minute. So here's the pattern again. So the pattern is the same as far as the naming. So when we look at the general form, it's always going to be ATE. If we take one oxygen away, the sub is subtracting. If I'm taking one oxygen away from the general form, I'm going to change it to ite. If I take two oxygens away from the general form, I'm going to add a prefix hypo and change the ending also to ite, or keep it from the -1. And then if I add an oxygen to the general form, that's what the GF is, the general form, I'm going to add a prefix per and keep the 8. So if we look at the square section, what's going to be different is the square has 4 sides, so the general form is going to have 4 oxygens. So sulfate, SO4, is part of the square section, so that's going to be 4 oxygens. If we add an oxygen to the square section, any element in the square section, if we add an oxygen, we're going to name it per 8, so like per sulfate. If we take an oxygen away from the general form, SO3, sulfite, and if we take 2 oxygens away, SO2. So what's the difference then with the 7 section? Well, the square in the 7 section, the difference is how many oxygens it starts with. So the square, the general form, started with 4 oxygens, and the 7 and 3 are both odd numbers. 7 section, and 3 are both odd numbers, and they're going to start with 3 oxygens. So if you notice, 3 oxygens minus 1 oxygen, it's going to be ite, minus 2 oxygens, going to be hypoite, and if you add an oxygen, it's going to be per 8. So again, let's look at the idea here. Something to remember, easy to remember, if your polyatomic ion has 5 oxygens, it will always be per 8. So if we look here, there's no 5 oxygens in the 7th section, so it has to be this per 8 from the square section, as well as if there's only 1 oxygen, it has to be hypoite. So again, if we look here at the chart, we have hypoite here can only be from the 7th section, not from the square section. So let's look at an example, sulfur. Okay, so the general form is going to be SO4 -2. Okay, so that came from that original sulfur square area, and we're going to name it sulfate. So if we take an oxygen away, everything else stays the same, SO3 -2, and we're going to change its name to sulfite. If we take 2 oxygens away from the general form, we get SO2 -2, and now we're going to change it to hyposulfite. And last one, if we add an oxygen to the general form, we get SO5 -2, and we name it persulfate. Okay, so if we take an example from the 7th section, same thing. General form now has 3 oxygens, NO3 -1, nitrate. We subtract 1, NO2 -1, nitrite. Subtract 2, NO -1, hyponitrite, and add an oxygen to the general form, NO4 -1, pernitrate. So what I would do now is pause and then check your answers. At this point, I'm actually not going to talk. I'm just going to click away. So you can pause as you go along, either do all 4 and then check your answers, or do 1 at a time, because that's how I'm going to be showing you the answers. So ionic compounds, just as a brief reminder, is a metal with a nonmetal or a metal with a polyatomic ion. Remember that because they have positive and negative attractions, they're oppositely charged, so they're attracted to each other. They're also going to be called salts, so we're going to keep that in mind. Sometimes we refer to these ionic compounds as salts. And that's it. So I am expecting many questions from you guys about Slivka square in this section because it is something new, or you can just memorize all of those polyatomic ions, which I do not recommend. All right, see you in class.